Ali. Welcome to our office hour. I'm very excited to introduce Yogendra Pandey, and he's one of our mentors. Just we need to know a little bit more about his background. How did he join data science, and what makes him tick as a data scientist? Yogi, I'll handle the mic to you.
Thank you so much, Mohammad. Thank you for the introduction. So just a brief background about myself. I got my undergrad degree in chemical engineering from the Indian Institute of Technology, Varanasi in India, and worked for a few years in India in software solutions development companies. And then I came to the United States in 2008 for my PhD in chemical engineering. My specialization during my graduate school was on high performance computing for complex systems, and a lot of statistical thermodynamics was involved in it. So that was kind of where I started getting serious about statistics and large scale computational systems. Along the way, I did get some exposure to teaching as a teaching assistant, where I had opportunity of teaching a class to incoming graduate students for statistical thermodynamics. And I also did TA work for undergraduate numerical methods and statistics courses. And as it happens during the grad school, you have a lot of interaction with other students. So some of the students were working heavily on statistical analysis, in particular for oil and gas industry. And that students ended up becoming my wife in the future. So I had a lot of overlap and interaction during that time with the statistical methods for oil and gas industry, discussions which led more and more me towards the oil and gas industry. Being in Houston, that was a natural choice. So after graduating, I started working with Halliburton, which is one of the prominent oil and gas services industry player. Then initial part of that was working for stochastic modeling for unconventional oil and gas reservoirs. And from 2013 to sometime I did that. And unconventionals are known for having a lot of data involved. You drill a lot of wells and you get a lot of data. And traditional methods are not as effective as they are for the conventional oil and gas resources. So there was a push coming in for data analysis and developing data-driven insight. And I had a chance of being involved in a product development team where we were trying to build products for multivariate data analysis. So again, I had that exposure to something which was not formally called as data science yet, but now when I look back, connecting the dots, I can very clearly see it's all what are the basic building blocks of the data science. My complete transition to data science was more of a coincidence. One day I was sitting in my office. I was already taking stock of the situation, and I was realizing that data science is going to be here soon. So I had started doing courses in machine learning, and some of my background with HPC already had a lot of understanding of scatter gather with MPI and sort of systems. So some of the other things in the machine learning world were coming from Spark. So that was also sort of interest where I was trying to see how things are developing. And while all of that is going on as a side activity for me, one of my senior manager came to my desk and asked me, Yogendra, we have a new project starting and we would like to have you on that. Are you interested? I didn't know what it is. So I thought trying something new is never going to harm me. So I said yes. And then he told me, okay, go to our chief architect and talk to him. When I went to our chief architect and talked to him, he told me that it's a project where we are going to use deep learning for doing some kind of modeling that we conventionally do. But we are going to use deep learning, and the idea is to explore the entire sphere of machine learning related algorithms and then see how we can use one of the candidate algorithms to provide a proof of concept, and then we'll take it from there. So I would say that was my formal induction into data science as we know it now. So from there onwards, I started building a lot of machine learning based systems and algorithms for oil and gas industry applications. Further in that experience, I had a chance of interacting with Microsoft Azure Batch AI team. So we did a proof of concept with them, and it had a good exposure. And I had the opportunity of being quoted in one of the blogs that Microsoft wrote about their experience with oil and gas industry using Microsoft Azure Batch AI service. And then around that time, I transitioned to another smaller oil and gas services company where I again had a role of data scientist and built some modeling tools based upon the data that was available with them. And then I worked with a small startup, which again was slightly different, but is still in energy sector, dealing with the utility, electricity. And I did predictive modeling for the load forecasting during my tenure with the startup. And finally, I ended up having my own small consultancy company that I started about 4 or 5 months ago. So that has been my journey. Currently, I'm focusing on developing data science-based solutions for my clients. And the other interest that I have is sharing my progress or my knowledge with others. So that was one of the motivation behind getting involved with the Springboard. So that's my short, concise journey. I don't know whether I talk too much, but yeah.
No, this
Regarding
is fascinating.
yeah.
So, like you would say, your first touch with data science was a growth opportunity within Halliburton when
Yes.
you offered an opportunity like this, and this is a good thing for all the people that are taking the courses with us, because usually they have a job, while doing that, and there's always a data science opportunity lurking somewhere. You can
Mm-hmm.
pitch that idea, or sometimes your management will pitch that, and this is something for you to start building into the field.
Yes.
Within the different roles, working for a big company versus a smaller company versus a startup versus your own company, how does your data science approach differ? Like the team composition, the techniques you use?
My experience has been, there are different ways that different companies work for sure. If you are working in a larger company, then there are more number of teams that get involved in the projects that you do. And the scope of the projects can be actually a lot more diversified due to the interaction with different teams. In a medium-sized company, the teams may be smaller, but what I have realized since the starting of the time when I started working as a data scientist, it's still in very early stage. So no matter which company you are working in, you are still going to feel that small startup-like environment. Problems come in, you have to start working on it. A lot of times you have to actually define the problem in a more concrete way, because most of the problem statements are often broad in nature. You are told that this is the problem that you have to solve. We are doing it in a certain way and we are not seeing the kind of results that we expect to see. So you have to start from there, and that's one of the reason I find data science discipline more enriching and exciting. A lot of times in conventional senses, you may have a very well defined path that you have to take. But in case of data science, a lot of times you will have a problem which is not very well defined, and you have some of the freedom intellectually to decide the course of solving that problem. So that's definitely one of the good side of data science. And always there's another side of the coin. So if you don't really like the problems which are not very well formulated, it might be a little frustrating. But again, at some point when you start enjoying it, the thrill in trying to chase a problem which is not very well defined and then come up with a solution which at the end of the day adds value for the business that you are working for, it's definitely very, very fulfilling and satisfying.
Excellent. Yeah, as you mentioned, communication is very important, and usually both sides of the equation, the stakeholders and the data scientists, there's some gap that needs to be closed.
Yes.
explaining what do they want and what can you deliver for them, and is this the exact scope of what we're working for. So for everybody, we're opening the floor for any questions you have. Feel free to unmute your mic and ask the question, or you can type the question in the chat, and me and AJ can read it. AJ, if you have any questions or follow-up, we welcome your input. My next question would be basically about your experience as a mentor. You've been working with few students, and you work as a teacher. You work as a TA during grad school, and in that capacity. What skill set that would make somebody coming into the field stand up among his peers or her peers, especially that you have your own startup? Hopefully, you'll be hiring data scientists soon as well. So your insight and your input and that would be very appreciated.
As far as it goes with mentoring or being able to teach, I think there are, from my side, I feel that first of all, you need to realize that once you were in a place where you didn't know what you are teaching. Mm-hmm. So going back, taking a few steps back, remembering the days when you didn't know it and you struggled through learning something. There's always a learning curve, and second part of it is to realize that different people have different learning curves. So it might have been that you didn't feel something as challenging as opposed to someone else who might feel it very challenging. And then there can be another thing which you feel very challenging and someone else can actually get it just by instinct. So as a mentor, probably it's really important, first of all, to understand what your mentee's learning style is and what they are going to learn easily and what they are going to learn with a little bit more effort. In the end, the idea is to share as much knowledge as you can. And definitely, I won't say that it's a one-way process. I always see, and that can be a selfish motive involved there. When you are teaching, you are actually learning things better. A lot of times you are explaining something to someone, and then suddenly something clicks to you. Oh, I didn't realize that this can also happen. And then you go back, you read, you learn it better. So I think it's a two-way process. When you teach, you learn along the way, especially with the data science discipline. It's very fast evolving field. Every day you see something new coming in, and you need to keep up to date yourself. And I think that's something that everyone in data science field is doing. It's a very vibrant community. People share their knowledge, LinkedIn posts, blog posts, or there are a number of resources. But the good thing about being in a program like a Springboard is you get that knowledge consolidated in one place. And as a mentor, for me, I also get up to date with what is going on in the data science world. And for the mentees, it's a good opportunity because they have someone who has already traveled that path. And everyone has different pitfalls or experiences, but it still helps to hear from someone who has some of those experiences and can share it.
Yeah, I agree with you. So you mentioned about the power utility. I work with a utility company in my current role. So what kind of stuff you guys are using to forecast the load? Sorry, this is like a technical problem. I'm just curious.
Yeah, I mean, I probably cannot go into the minute details of the model itself due to certain reasons you would understand. But the idea is to get as much data as available in the public domain. And
okay.
So, a lot of data for the day-to-day weather or other resources are available. And then there's also data coming in from your clients. So based upon that, you try to develop a model that best generalizes your
so you like basically you're mixing like demographics and geography, income level, adding more features to the load data of your client.
Yeah, I mean that's the ideal scenario where you can get a lot of information. Sometimes a lot of information is available, sometimes it's not. So a model that works with the least amount of data is probably the model that you want to make so that it's equally useful in different kind of scenarios.
Excellent. Yeah.
I know AJ did comment this, but it looks like we have a big group here. And if any students have any questions, regarding Yogi's experience or any advice you might have, please ask away.
Chime in, yeah. We'd love to hear from you guys.
Hey, Yogi, I'm not sure if you're able to hear me. My computer seems to be a little bit slow.
I can hear you.
But I was curious to see if you could share with us like the top oil and gas problem that you are aware of that people are interested in solving using machine learning.
Sure. So there are certain problems which are really pressing needs in the industry. One of them would be equipment failure analytics. Some people might consider it a solved problem, but as you know, once you solve a problem, the need for making the accuracy higher keeps on coming back to you. And if we think about oil and gas industry, there are a lot of machinery which gets used in the process. If one of your machine fails, just putting it in the perspective, there are times when you have a drilling rig setup and the daily capex for that could be $1 million. And if one of your equipment fails, you have rented that rig and you don't drill for that day, you lose $1 million. So that's one of the reasons why people want to have a alert ahead of time if something is going to fail, so that they can at least get a replacement, change it, and try to figure out and try to that downtime to the least possible so that they don't lose as much money. So that's definitely one of the very interesting problem. If we think about the other problem, as Mohammad was talking about, forecasting. So whenever you have a new well coming up, you want to know how that well is going to produce in future. So if you know that a particular well is going to produce well or it's not going to produce well, based upon that, you can make engineering decisions and try to do certain remedial actions so that you don't lose productivity on that well. So forecasting definitely is one of problems which is of very high importance. And then I would come to the actual holy grail in terms of big data, and that would be the geosciences. So for the subsurface and geosciences, there's a lot of data available. For example, the seismic surveys which are done for the subsurface, they have a lot of data. And in fact, I'm aware of one of the Kaggle competition going on where there are seismic images available, and the idea is to figure out where there's salt dome, because salt domes are sometimes working as a seal, or certain drilling decisions have to be made based upon where the salt domes are. So people try to figure out from the seismic where that particular salt deposit is, and that helps in making a lot of decisions. So that's particularly semantic segmentation problem for which one of the Kaggle competition is going on right now. And again, for drilling automation, a lot of people and companies are trying to make an autonomous drilling system, which is a combination of artificial intelligence, which means in turn data science and robotics. So oil and gas industry really is very rich in terms of the use cases for data science and machine learning, artificial intelligence.
Excellent. That was actually my question for you about having any public data for people to train on using, even data for the oil industry. And you say the seismic survey is available in that regard.
Yes, so Kaggle has it. And other than that, there are also a few data sets. I'm sure that it's open for at least university and academic research purposes. It's from Statoil, which is now known as Equinor.
Okay.
So from one of my friend who told me it's about a 4 terabyte of data set, if what information I have is correct.
Excellent. So we have questions over here on the chat. So let's see. We got a question from Jisha. What's your suggestion about specializing in deep learning and natural language processing? Is there a better choice between these?
I would say the choice it depends upon the pretext of that question. If you are coming from the availability of the number of jobs, definitely there are a lot of jobs in both in deep learning and natural language processing at this point of time. Especially with the social media analytics kind of problems, NLP is definitely a very important skill set to have. Deep learning in that sense is a broader umbrella term, so you can be actually solving a lot of problems within that umbrella. If you want to specialize in computer vision, and then that has direct applications for autonomous cars, and who knows, in the future, autonomous planes too. So both are definitely very good choices for career. It also depends upon your personal interest. So I would say when you are making a call for choosing a specialization, while it's important to see that there are a lot of jobs in that field, also see what interests you more, because that's probably going to be your career for the initial few years. So you should like it.
And I might add to that, these are not mutually exclusive disciplines.
Yes.
Like one of them is a technique to solve problems,
Yes.
and one of them is a problem to solve. Is a problem.
Yeah. I mean, one is a larger umbrella, and the other one is a part of it. So
excellent, thank you. The next question I see, it's what are the common models or functions that you use in your role?
It definitely depends. I mean, to be honest, it can be anything from a linear regression model to a deep neural network, depending upon how much data you have and what is your final, requirement. If you don't have enough data, definitely deep learning is not a candidate. So you have to probably fall back to more conventional models. And just to add, I mean, there's no need to use a deep neural net if a linear regression model is giving you good results. It's all about having a good model that solves the business problem at your hand.
Correct.
But just since you are asking me the common models and functions, lately I've been using a lot of light GBM, and it's becoming more and more popular as the time goes by. A lot of times problems can be solved just using a simple support vector regression or classifier. So it entirely depends upon what kind of problem you have at the hand to solve. But if you have a lot of data, yeah, definitely I like to use deep neural networks and see how well they work, and if I'm getting better accuracy using deep learning versus a more, say, cheaper model in terms of computational cost.
Yeah, sometimes, how they say it, sometimes a pair of scissors is all what you need to solve a problem.
Yeah, exactly.
So we have a question from Sriram, unless he wants to unmute his mic and ask it. Okay, I'll go for it. Ayubi, have you done any projects on forecasting the energy consumption for process industries?
Well, I mean, I think the question that he is asking goes into the part of, you have a number of appliances or say equipments, and then you want to, well, get the contribution of each of that equipment in the overall load that you are seeing at the end. So yeah, there are models available, and you can, if you do a quick search on GitHub, you'll probably find a few projects which are already there. I'm familiar with one such project on GitHub that uses LSTMs. There is another project which uses a simple clustering based approach. So, depending upon what you are looking for, there are actually open source implementations already available for this kind of equipment level load disaggregation or energy consumption disaggregation.
Great questions from attendees. I had one, Yogi, I wanted to ask, and this might be a little broad, but I think for you, being in the industry, being somebody that looks or sees people coming into the industry as junior data professionals, curious what you believe can help aspiring data professionals stand out from the pack. What are things that you might look for in recruiting people to come work alongside you or under you?
One thing that I personally feel of great value is if people who are trying to get into data science discipline, they try to pick up a data set when they are doing a project which has more sense from the business standpoint. A lot of times people start with the Iris data set or Boston housing prices data set. These are good beginner data set, very clean data sets. You start using them and right away get good results. The reality of business is you never have a clean data set. So it's always going to be a data set which is most likely not going to give you anything right away if you try to use it. So my advice would be try to go out and look for more realistic real life data set. And there are quite a few resources. On KD Nuggets, there is a web page which lists a lot of open source real life data sets. UCI machine learning repository is another source where they have a lot of different problem related data sets. And there's a GitHub page that lists a lot of open source data sets for data science. So depending upon which field interests you more, I think it's a good idea to choose one of these data sets coming from the real life scenarios and try to build a model with that. Now, model is a part of the entire story of a data scientist. So we should never forget that if you are building a model and we are not connecting it to business value, then it's hard to sell. I mean, you can have a good model, but if you cannot sell it, then it does not create a business value. So you probably need to figure out a way to convert the value of your model into dollars. For example, if you are saving time for a particular process by making a predictive model, then try to assess, even if it can be a very rough or say ballpark number, it helps to put that number with that model. If we use this model, the process is going to improve, and then maybe $100,000 or maybe $1 million or maybe a more than that. That's the impact on the business bottom line. So I think putting things in that perspective and having that kind of approach is definitely going to help in the data science interviews, because at the end of the day, people are looking for generating more value by having a data science team.
Yeah, thank you, and great answer. Absolutely.
You're welcome.
Another sentiment that I've heard from other mentors. So yeah, we got time for another question or two if any students want to add on, or else I'll leave it to Mohammad and AJ. Ooh, great question from an attendee. Nirmal, do you want to ask that yourself? Cool. Well, I'll ask it. It's an awesome question. Very simple. Great one. Oh, yeah. Nirmal, are you there?
Yeah. What's the hardest part that you had to learn from as becoming a data scientist?
Well, I mean, don't fall in love with your models. It can be that sometimes the scenario becomes you cannot see the wood for the trees, and models are there for a reason. But if you are romanticizing with your models more than you need to, then for you it may be a big difference if you increase your model accuracy from, say, whatever metric you are using, and it's 0.91. You spent a couple more days and you made it 0.9101. For you, it's an improvement. But if it does not really make an improvement for the business decisions being made, it's not really helping the business. But it's equally difficult for you to stop when you are in that flow. So I think that's the hardest thing, in my opinion. Not going in that unidirectional mind and not knowing when to stop.
That is a very good point. That's also, it helps to have groups working on a problem.
True.
different approaches to that. Your biases, somebody else usually sees something that you have a blind spot to that, et cetera, et cetera, et cetera. And it's
Yes.
a lot easier to digest and or like try to improve on somebody else's work versus your own.
Mhm.
Let's see. Do we have time for one more question, or are we done?
If there's a burning one, we can ask one more.
Just basically in terms of like resumes or pitching oneself as a data scientist, going to meetups, lectures, conferences, sending your resume old traditional way, somebody knocking on your startup door. What is the best piece of advice you would give to data scientists in marketing themselves, Rudy?
I think one of the thing I can think of is networking by meeting people in person.
Mhm.
If I look at the number of LinkedIn messages that a lot of people get these days, it's probably difficult for people to respond to each and every single message that comes their way. Even if you want to help, you cannot. But the people who you meet in person, if they tell you, I need some help, you'll probably definitely try to do that. And it might be as simple as taking your phone out and sending a few messages to your friends that you know and ask, hey, this guy is good and can you help him? So I think that personal touch is definitely needed when you are looking for a job, and definitely having a good LinkedIn profile. And if you can write a blog or have a good GitHub profile, that all of that helps you in building your portfolio. So I would say it's not one single thing, but yeah, it's a mix of things.
And this is, mostly relevant, since you live in Houston, right?
Mm-hmm.
It's a small data science market over there compared to San Francisco or New York or et cetera,
Yes.
et cetera. So definitely if somebody in that area, it's worth a while to, say hello. Can I have some coffee with you just to pick up on your mind, this and that?
Sure.
But you have to do your due diligence, build a good profile, show that you're serious about this.
Definitely.
Excellent.
I think this is a great question, and if people do have to go, but I'd love to ask this, and I think having you here has been so valuable, so insightful, and so I'd love to get your answer to this one from a student named Vivek. Asked, what role data science can play in driving a future of renewable energy or clean energy? Is that something?
Well, I mean, definitely there is a lot that can be done in that direction. I can probably give one or two examples. For example, if you think about wind energy, there are possibilities of making models. You can know what weather is going to be in a particular region, and then based upon that, you can predict ahead of time how much energy is going to be produced. As far as it comes to optimization of the entire grid that will make based upon that, because I know this because there are parts in Texas where they make energy and then they have to sell. Basically, they have to sell at a negative rate because they are producing so much, they have to give it to someone.
You can't store it.
Yeah. So, I mean, there are definitely opportunities. If you can come up with a model that optimizes the entire production line, storage is a big part of that. So I won't say it's a data science standalone problem. It's probably going to need some understanding from the entire, say, value chain that's there for the renewables. Definitely not my expertise, but from working briefly in the utility industry, I do realize that there are quite a few possibilities in terms of, predicting ahead of time how much you are going to produce and how do you actually distribute it. From that perspective, commercial perspective, you can do that. Other than that, I cannot think right now. I mean, I cannot think a very pressing example right now due to lack of experience in that field. But yeah, same thing can be said for the solar industry. Predicting ahead of time how much you are going to produce based upon some data from the weather stations or things like that can really help.
So like, a couple of examples just from the news cycle we're having these days. So now they're trying to, usually you're only allowed to add ethanol to fuel in winter. So the federal government is considering removing the ban for summer. So ethanol will become from 10% to 15%. Just predicting how this is going to affect the car industry. This is $1 billion problem. Probably tens of billions, because cars that are older than 2001 will get negatively affected by that because their engines might have issues with that, etc. Also, like he mentioned, storing the energy, etc., being able to build a smart grid and predict, like if you generate energy from the East Coast and trying to push it to where they need it, this is a $1 trillion industry actually. There's that. So
yeah, well, great question. And Yogi, just want to say thank you for staying late as well, for taking time. We're excited to have you as part of our community, and we thank you for joining us today.
Thank you so much for giving me this opportunity. I really enjoyed this interaction, and I hope to be part of such interactions in future too.
Yeah, we'd love to have you back for sure.
Mohammad, great job, you guys.
Mohammad,
to the attendees, me and Molly we're quiet today. I know for you guys.
Unusual, very unusual.
Very unusual. Wow.
it was a one-off.
Everyone's like, finally.
Like, we can learn something again. Data science, yes.
Hey, thank you all. To everyone, have a great weekend.
Next week.
Yep, next Thursday. See you, everyone.
Love a
Thank
project.
you so much.
Bye-bye. Thank you.
Bye.